Have you ever heard a 100 kVA inverter is generating 100 kVAr of reactive power and you are thinking, is it really true? So how much reactive power an inverter can generate or absorb? Is it limited or unlimited or restricted? And what is the maximum capacity an inverter can generate or absorb the reactive power? Hi everybody, welcome back. If you are working with a solar plant, this video is for you. We will see inverter reactive power limits, grid code limits, and the inverter PQ capability curve with the 4 quadrant operations. Be with the video. Let's start with the golden rule, and honestly it will solve half of the confusion. The inverter is rated in kVA, not kilowatt. So active and reactive power both consumes the same inverter capacity rated in kVA. Look at the power triangle where S is kVA, P is kilowatt and Q is kVAr. So whenever reactive power increases, active power must reduce and vice versa. Think inverter capacity like a fixed size bag. It can be filled with either active power or reactive power or mix of both. So active power is actual energy, reactive power supports voltage and system stability. So apparent power is total inverter capacity in kVA. So reactive power is not extra capacity, it comes from the same inverter limit. Ideally, an inverter can convert entire kVA into reactive power when there is no active power. So 100 kVA inverter can generate 100 kVAr of reactive power when active power is 0. But in real world, most grid allows operation between 0.8 lagging to 0.8 leading power factor. PQ capability curve shows P on y-axis, Q on x-axis. Left hand shows lagging power factor mode, right hand shows leading power factor mode. PQ capability curve shows the range of power factor 0.8 lagging to 0.8 leading. In lagging mode, inverter accepts. In leading mode, inverter generates reactive power. With a calculation, you will find inverter can generate or absorb maximum 60% of its kVA rating as reactive power at 0.8 power factor. To understand the inverter 4 quadrant operation, interchange the P and Q axis in PQ capability curve. Now P is on X axis, Q is on Y axis. 4 quadrants starting from 1 to 4 in anti-clockwise direction. Modern inverters operates in all 4 quadrants, meaning they can supply or absorb active power and supply or absorb the reactive power. So when grid voltage rises, inverter absorbs reactive power. When grid voltage drops, inverter supplies reactive power. A standalone solar plant inverters operates in quadrant 1 and 4, and when BSS system is added with the solar plant, the inverter can operate in all 4 quadrants anytime, day or night. In quadrant 2 and 3, when inverter accepts the active power from grid, it recharges the battery in BSS system. So now the plant becomes not just a generator but a full grid support asset. Let's recap the key takeaways from today's video. Inverter reactive power capacity is limited by kVA rating. Grid codes decide the inverter operation window, which is generally 0.8 lagging to 0.8 leading. Grid code limits maximum 60% of inverter kVA rating as reactive power. Modern inverters are capable to operate in all 4 quadrants. Inverter in standalone solar plant works in quadrant 1 and 4. An inverter in solar plant with the BSS system works in all 4 quadrants. If this helped you to understand the inverter reactive capability in practical way, hit like, subscribe, drop your comments, and in next video we will see why grid shows 0.8 lagging to 0.8 leading power factor.